Over the last few lectures, we have looked at scientific inquiry through the lens of climate change. We have looked at how scientists discovered the mechanisms by which the Earth's surface is warmed by the presence of greenhouse gases in the atmosphere. Recognizing the influence of greenhouse gases, we saw how scientists were able to predict the consequences of increasing the atmospheric concentrations of CO2. We learnt how doubt about climate change was used to prevent regulation being enacted to mitigate climate change. We delved into why the public is susceptible to climate change denial. What types of cognitive bias make us susceptible? It is important that we arm ourselves with a critical thinking arsenal and a basic understanding of climate change if we are to be part of an informed citizenry to engage in the conversation about how humanity should confront the challenges of climate change. It was the space engineer and journalist James Oberg who said, "Keep an open mind, but not so open that your brains fall out." How should we approach new knowledge that challenges our own preconceived notions? A useful approach might be to consider Bayes' theorem. However, let's not delve too deeply into the mathematics and apply our critical thinking skills. A classic problem you have perhaps all been asked in high school would be to consider the following scenario. Suppose you wake up in the morning feeling a little rough and decide to visit your GP. The doctor is perplexed by your symptoms and decides to run a battery of tests. When the results come back, it appears that you are positive for a rare and nasty illness that only affects 0.1% of the population. Given the nastiness of the illness, but also the discomfort of the treatment, you ask your doctor, what are the chances that the test result is wrong? Your doctor tells you that the test will correctly identify 99% of people who have the disease. So the question is, what is the chance that you do indeed have the disease? A naive reading might lead you to think that it is 99% certain that you have the disease, but as you probably remember, this is wrong. Let's determine this critically. Say we have 10,000 people in a population. 0.1% of that population, or 10 people, will have the disease. But if we were to test the entire population, then 100 people would falsely test positive. The test has a 1% false positive rate. So that means that the chances you have the disease is 10 chances out of 110, or about 9%. That is not very high and far lower than the 99% accuracy of the test. So you decide to go to another doctor who uses a different laboratory for running tests, and you ask for a second opinion. When you get the result back, it is positive again. What are the chances? Well, let's suppose that the two tests are independent of one another. What would be the chances of falsely testing positive twice? That would be 1% of 1%, or 0.01%. That means in a population of 10,000 people, one person would falsely test positive twice. But of that population, 10 people still have the disease. So now the chances that you have the disease are 10 chances in 11, or about 91%. As more evidence comes in, we need to update our estimates as to whether something is true, even if our perceived chance of it being true, 0.1% chance in this example, is very small. We are all susceptible to bias, to take on different forms of denial. I remember in the early 2000s, when the research about the carbon footprint of various diets was beginning to be published, that showed meat having a larger footprint than vegetables. As a meat eater, I found this research disturbing. I enjoy meat, and yet my diet was contributing to climate change. So, I denied the research. Who wants to be the villain? I argued that the research hadn't taken account of changing land use, the carbon cost of deforestation to provide the additional land required to grow the necessary crops. I argued about the degradation through the use of pesticides and fertilizers. However, over time, these arguments were tested, and still the result that meat production has a greater carbon cost than vegetable production became steadily more robust. I had to swallow my pride and admit that I was wrong. I also had to change my behaviour. Although I still eat meat, I eat far less than I used to. These are the personal changes in behaviour that we can all make. Recognising that our opinions are fallible, being willing to acknowledge our fallibility, and to make lasting change to behaviour. To end, I want to echo the words of Jacob Bronowski towards the end of the chapter Knowledge and Certainty in his book, The Ascent of Man. He said, "Science is a very human form of knowledge. We are always at the brink of the known. We always feel forward for what is to be hoped. Every judgment in science stands on the brink of error and is personal. Science is a tribute to what we can know, although we are fallible. In the end, the words were said by Oliver Cromwell, 'I beseech you in the bowels of Christ, think it possible you may be mistaken.' There is a real danger to have absolute certainty, to dogma that closes the mind. Be open to test your reality. Don't fall to the arrogance of knowing the truth. I hope that this module has provided you with some of the insight that scientific inquiry provides about how one should go about learning what is true, even if we know we cannot be certain. Thanks for listening.